Again, talking about misleading information, misleading graphs, we're focusing on the things that can create information to be misleading. So if you weren't to look at the numbers and you were just to look at the graph itself, do they look the same? No. In fact, one of them looks like it's a little bit of a steeper rise than the other, right? So if you were to say, hey, which one of these graphs has a sharper increase in the price, would you say that it's graph A or graph B? Graph B, right? Graph B looks like it has a greater rise that's occurring. Now, on the flip side of that, if you are a member of student council and you're trying to promote ticket sales for a dance, so let's say these are, talking about the prices for the spring dance that's coming up, and you want to basically tell people, hey, the price really hasn't changed that much. Which graph are you going to go with? Graph A, right? You want them to believe that there's really not that much of a change. However, both of these graphs are actually identical. They are exactly the same thing. The only difference, if you zoom in, are the numbers, right? Not the years. The years are exactly the same. It's the numbers that are a little bit different. Get that zoomed in. So if we look here on the graph A, what are we counting by for each of these bars? Fours. So this one's counting by fours. And then for graph B, what are we counting by? By twos. So here we're going to count by twos. Do you have a question? So graph A is counting by fours, graph B is counting by twos. So that's a problem here. The larger the interval count, the more misleading the graph can become. Because even if I want to say, hey, in student council, we note that there's really not that much of a change. In reality, to go from year 2006 to 2010, the price doubled. Doubling the cost is a pretty big deal. Okay, so large interval counts can be misleading. Go ahead and write that down. That large interval counts are misleading. In fact, your idea is that you want to have smaller counts. The smaller the count, the more detailed you can see. Smaller the count, the better the details. It's almost like you're taking a microscope to the graph and you're being able to zoom in and see it. Kinston? Yeah, you're not being able to see the significant changes that are occurring from year to year when you've got a larger graph. So for example, if I were to do this, instead of going from 0 counting by 4s, maybe if I count by 8s, it's really not going to show much detail because you're going to be like, oh, well, it's right here. I mean, you'll only see little bars between these two lines. That's all you would see. So you really wouldn't see any kind of detail at all versus if I even change this and count by 1s, then I'm going to see even more significant change. So the smaller the interval count, the more detail you're going to be able to see. All right, so let's go on down to example number 2. Example number 2 is with a line graph and not a bar graph. Bless you. So again, here, these line graphs are showing the profit that a company can make is making between October and March. And if I were to choose, like let's say that, hey, I'm going into a board meeting and I'm trying to get potential investors. And the only way I can get somebody to invest in my company is by showing them that I'm making a lot of money and I'm making it quick. Which graph am I going to show them? The first one. The first one's going to make it look like I'm making a lot of money real fast, isn't it? Because it's shooting straight up. But here's the problem. Both graphs are exactly the same. They represent the exact same information. Here's where the issue is. If we look at each of the graphs, we started at 14,000. They each counted up by 500 to get to 14,500. Then they each count up by another 500 to get to 15,000. But then graph B continues to count by 500s, whereas graph A, or the first graph, then changes and decides, I'm going to now count by 100. So it changes the interval count, and that's not allowed. Changing the interval count is going to cause a misleading information, because from this point of view, from here to here to here, everything is identical for both graphs. It's not until we change the count that things start to look different. So it looks like it's making a huge change, but really to go from January up to even March, it's only a $400 difference. That's not a lot of change at all. So that's the next issue. Again, so we're going to write this off to the side. Hey, we started counting by 500s, but then all of a sudden we're counting by only 100s. So having that change occur is not allowed. You cannot change the interval count. Now, some people probably ask, hey, well, we started at 0 and we went to 14,000 and then we started counting by 500. So isn't that an interval change anyway? It's not, because this little thing right here, this zigzag that you guys see, anybody know what that's called? Anybody? It's called a break in the graph. And a break in the graph is letting you know, hey, from 0 to my first value, it's going to be a large jump. I'm making a large jump because there's not any important information that I need to yield or to explain from 0 to this point. There's nothing going on. Nothing really good. None of the real meat is happening until I get to this point. So I do a break in the graph to get to where the important stuff starts. That break in the graph is the only time that you're allowed to have a different count. So here, yeah, I jumped by 14,000, but then I need to continually stay counting by one single value. So if I want to count by hundreds, I count by hundreds. If I want to count by 500s, I count by 500s. But that first part can have a big jump. Okay? Any questions? All right, so large interval counts are considered to be misleading, and changing your interval count is going to be considered misleading. You also need to be very, very careful about picture graphs. So let me go ahead and write that down down at the bottom. Picture graphs. Tend to be misleading. Because people focus on the size of their pictures instead of the actual value that the picture is worth. So a lot of times you're like, oh, this small picture is a smaller number, but now the next picture doubled in size, so that must mean it doubled in value, when really it might have only increased by, a quarter of the value. So you have to be wary of that. He's on his way. Thank you. Notes will be online, sweetie. Yeah. I don't have a color pencil sharpener. That sucks. Sorry. Yep. You will. You'll see them on news channels, news outlets, newspapers, different blogs, all sorts of things. And it's not just news. A lot of people use them. Okay? All right. Let's go on to the next page. So we want to do this quickly because you guys are leaving soon. All right. The last thing that can be considered misleading or causes information to be misleading. So here, we're talking about a roller coaster, and a roller coaster park or an amusement park is boasting that they've got roller coasters with an average height. What's average mean again? The mean. So if we say average, average means mean. So they're saying that it has an average height of 170 feet. And hey, if I actually calculate this, yeah, it does come out to 170. You know, if I add all these numbers together and then divide it by 5, I will get 170. So that's not wrong. They didn't fudge the numbers. But what's creating an issue is that I'm going to go to show up at the park and go, okay, here's one roller coaster. Oh, it's 109. Blah. Here's Monster. It's 135. Blah. Here's Rip Zip. 115. Blah. Oh, Riptide. 126. Blah. The only one that's boasting anything really great is the Tornado at 365. So we're noticing here, hey, even though it has an average of 170, 4 out of 5 are actually smaller than the mean. And the reason that that happened is because of that tornado, the 365. Who knows what we call that? An outlier. That is called an outlier. And so when there's an outlier involved, outliers cause the mean to be misleading. Outliers are going to cause the mean to be misleading. So whenever there is an outlier involved, the mean is not a good representation. You'd want to use the median instead. So write that down. If there is an outlier, the median is the best representation. If there's an outlier involved, the median is going to be your best representation. Now, real quickly, a nice little side note that you need to know. If you see anything in today's assignment that says measures of central tendency, if you see anything that says measures of central tendency, they're talking about the 3 M's. That would be mean, median, and mode. Now again, because you're leaving in just literally 2 minutes, I'm going to go ahead and do this problem right now. If we're finding the mean, who remembers how do you find mean of a number? Add all of them and divide by how many there are. So it's basically add, count, divide. So we're going to add all these numbers together. So 1,700 plus 1,400 plus 350 plus 1,600 plus 1,400. We're going to add all that together and divide it by 5, and that's going to equal 1,290. Okay, then if I were to go ahead and do the median, how do we do median again? Put them in order from least to greatest. Very good. And then it's whatever's in the middle. Put them in order least to greatest. So our smallest number is 350. Then we're going to go to 1,400. Then 1,400 again. Then 1,600. Then 1,700. So the middle number is that 1,400, the second one. So your median is 1,400. Then the last thing, talking about mode. What is mode? The most repeated number. It repeats most often. So that would be 1,400. The mode is the value that's going to repeat. Now, when they're asking which measurement is misleading, which one of these 3 measurements is misleading? The mean, because there is an outlier. So the mean is misleading because of the outlier. That's $350. That's our outlier. Okay, you have a worksheet tonight. It's only 10 questions. Please make sure that you get it done. We're going to be turning it in, and I will be checking it. You've got your quiz tomorrow.